Well, greetings, everybody. So what you see here is a problem that somebody sent me from the assignment on my math lab, and I think it'd be a good problem to go over. As you can see, it's a problem that requires some reading. I have to read this. I have to understand the information given. I have to figure out what to do with that information, and so on. And because that's a key part of this particular problem, then I thought we could start by talking about this. What type of problem is this? How would we recognize it if we saw something like this in the future? And if we do recognize it, how would we solve it? I think that's a good place to start with this one. And I wanted to organize it that when we read the problem, it's giving us certain information. It maybe is telling us we're doing something and that we want to calculate something, okay? And then how we do that. So I broke it down to those parts. So here's the type of problem that you'll see if I read this one up here. Here's the type of information that will be given to me. So what they will give us, we will have a population of some kind. Okay, the population could be anything, any like the ages of all students at TCC. That's a population. Okay, and there will be a population mean, like say the average age of the students, and a population standard deviation. Okay, so real quick, I use these letters a lot throughout the class, and we do this in math. We use a lot of Greek letters, okay, for different things. And you'll see mu and sigma as the Greek letters that we use for the population mean and population standard deviation. We'll see that over and over. So, but those are Greek letters. In case you aren't familiar with the Greek alphabet, I just want to tell you, like, my handwriting is not always so good with the Greek alphabet, but see that letter right there? That's lowercase mu, okay? That's the population mean. And you see this letter right there in the middle, okay? That's sigma. That's lowercase sigma, which is always the symbol we use for the population standard deviation. All right, so I didn't want to leave that out because I use those symbols. I'm gonna call this one mu and that one sigma. Okay, so we'll have a population. We'll know the mean of the population. We'll know the population standard deviation also. Example, the ages of all students at our school. Then from there, if we read that problem, so this problem up here, if I read it, it'll say something about taking a sample of a certain size. N is always the letter we use for the size of a sample, okay? And we will calculate the mean of that sample. So I might have population, the ages of all students at our school. And then maybe I take a sample of 100 students and I find their mean age or something like that. Okay, so, but all right, that's what we have. We'll have population, we'll know the mean and the standard deviation of the population. We'll take a sample of a certain specified size from that population and we'll calculate the mean of that sample, okay? And then here's what the question will turn out to ask us. Can you calculate the probability of some kind that involves the mean of the sample? So say, like, what's the probability that the mean of the sample is more than 20, okay? Or what's the probability that the mean of the sample is between 20 and 30 or something like that, okay? So that's what it will be asking us for. Calculate a probability involving the mean of the sample somehow. How would we do that? So this is all what we read in the problem. This is the information we're given, and this is what it's asking us for. How we do it? Well, you can calculate that probability by using a normal distribution with the mean of mu, which is the same number as the population mean, and a standard deviation of sigma, the population standard deviation, over the square root of n, the sample size. I say use a normal distribution. Well, how do you use a normal distribution? Well, one way you can do it that's pretty easy is you can go to StatCrunch, you can go to calculators, and then you can go to normal, and you can do calculations very easily with a normal distribution that way. So that's what I mean when I say we'll use a normal distribution. You will have to specify what the mean and standard deviation are supposed to be, but in my notes, I just told you mu and sigma over root n. Okay, so let's read this question. Does this question give us information of this kind? Okay, now when I read it, like, I might think, well, maybe you don't know much about the Dow Jones Industrial Average, but I can look at this like there's a population like I get the mean annual gain, whatever that is, of the Dow Jones Industrial Average, okay, uh, from 19 all the years 1975 to 2020, okay. So, all right, I get the annual gain for each of those years, and I know the mean is 652. So the population is the annual gain for each year, and it tells me I know the mean of those annual gains for each year. So it sounds like I've got a population, and I've got the mean of that population. What else do I see? A random sample of 31 years. Okay, so I got the population. I'm going to take 31 of those years. Okay, so that's a sample of a certain specific size. Okay, and then it says, what's the probability that the mean gain for the sample was between 400 and 800? Assume sigma, the population standard deviation, is 1541. So it sounds like we have all that. I got population annual gain of the stock market for each year. Okay, I know that the mean of the annual gains for all those years is 652. That's mu. And the standard deviation, it just told me. I didn't even have to dig for that. It said 1541. Okay, now we study sample size 31. Okay, 31 different years. That's our sample size. That's in. And calculate the mean of each sample. Okay. And the calculation that we're looking for, the probability calculation, is what are the odds that the sample mean from that sample is between 400 and 800. So can you agree that sounds like this? We're given all that stuff. Read that question. The have is the same. The want is the same. And now let's talk about the how. How would we do it? Well, if I'm going to calculate the odds, the probability that the sample mean is between 400 and 800, I use a normal distribution. The mean is 651, same as the population mean. And the standard deviation I use, sigma over root n, it was given to me, sigma is 1541 over root 31. That's about, with some rounding, 276.78. So with that normal distribution, let's calculate the odds of being between 400 and 800. Okay, so here I have StatCrunch, and I have the normal calculator. And I'm going to put all this stuff in and do the math as indicated. So mean 651, standard deviation 276.78. And I want to set this to between because this question did say what are the odds that the sample mean is between 400 and 800. Okay, so let's see. It gives me 0.5225. All right. Now, that will be it. That's the probability. It's like a 52% chance. Okay. Now, let's see. What does it say in that question? Notice that there's my number, the probability. What you'll put there is this number. Okay. This 0.5225. Now you will notice they're a little bit different here. That's a 0.5223. There are different ways you can calculate this number. StatCrunch is one of the ways, but there are also tables where you look this number up. That's not something I'm including in my class. You'll use StatCrunch, but even though this number, as you see it on the screen, is a little different than that one, there is some tolerance built in here, and it will accept your answer from StatCrunch. So don't worry about it. So there's your probability. And then what does this mean? I'd say, well, the probability is 0.52, so that means there's a 52.23 if you convert that to a percentage. Percent of the samples of those size 31 years will be somewhere between 400 and 800. Okay? All right, so that's how we do it. It turns out it's not that hard to do. I think StatCrunch does most of the work, okay? But I have to know how to read this and figure out that I'm giving or I have certain kinds of information. That's how I know how to solve a problem. So if I'm working on the assignments or I'm taking the quiz or the test, I got to read the problem. I got to figure out what is it telling me, what is it asking me to do, and then from there, I can identify the correct formulas and method to solve it.